Okay, friends, let's go into something just totally different from what we've been doing. This is actually, as we start this part, this is stuff you could have done in like Algebra 1 had we wanted to introduce it there. Maybe even before that. So we're going to talk about parametric equations. Parametric equations are equations involving x, y, and t. So it's kind of how x and y depend upon t. So how x and y change over time would be a good way to think about this. So build a table and figure out points, graph it. Okay. So what we want to do is plug in t values to find x values and y values. And I'm going to be lazy. I'm just going to pick -1, -2, 0, 1, 2. You may be thinking, whoa, you can have negative t? Yes. So 2 times -2 is -4, plus 1 is -3. And then 2 times -1 is -2, plus 1 is -1. Oh, that's just a line slope 2, so I'm just going to fill in the rest of that. And then 2 squared is 4, 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So that's the point -3, 4, -1, 1, 1, 0, 3, 1. I just got confused. And then 5, 2. All right, so that looks like a parabola. So it says use algebra to write the function. Let's see. If I have x equals 2t plus 1, then isn't t x minus 1 divided by 2? Take a moment. Process that. Subtract the 1 divided by 2. So that means y is x minus 1 over 2 squared, which is x minus 1 squared over 4, if I want to write it that way. So it's a parabola that's been shifted to the right 1. And then we have a vertical compression, I guess we'd think of it, factor 1/4. So it shrinks everything by 1/4. And I'm noticing that is incorrect. That should be a 4. Whoops. All right. How would I write the equation tangent line when t equals 2? So when t equals 2, just for fun, let's write down what x is. So x is 5, y is 4. So let's think of this, I don't know, let's think of this how we thought of it before. So we have x minus 1 squared over 4. So y prime is 2x minus 1 to the first times 1 over 4. Y prime when x is 5, 5 minus 1 is 4, divided by 4 is 1, so 2. So then the tangent line would be y equals the y value plus the slope x minus the x value. So that would be how we find the tangent line. Now there's got to be a way to deal with the t stuff. So let's think about this. Let's think of dx dt. That's 2. Let's think of dy dt. That's 2t. I want dy dx. Do you think that I just do dy dt over dx dt? Well, that would be 2t over 2, which is just t. So when t is 2, the slope was 2, okay. What about y prime? So when t is 1, x was 3. And so when x is 3, the slope is 3 minus 1, which is 2 times 2, so that's 1, which is 1. Okay, so that's seeming like that might make some sense. That might be possible. All right, define arc length. Oh, goodness. Let's see. So let's think of how we did this arc length idea. We did like a Riemann sum idea, where if we had some sort of curve, we kind of made little triangles, and to find this distance, we did delta x squared plus delta y squared and square rooted it. Then what we did is we said, okay, let's think of this in the notation that we're used to, dx squared and dy squared. And then let's go ahead and say, well, we want a dx out here because we're going to want to integrate. So let's put a dx here to compensate. And then we got things inside the integral, inside the square root. So we called that dx squared plus dy squared over dx squared with a dx on the outside. And then we could simplify 1 plus, oh that's right, dy dx squared dx. So for the one up here, find the length of the cosine curve on the interval 0 to 1. So that's your function. So your derivative, if that's y, is negative sine. So your integral is from 0 to 1 square root 1 plus sine squared x dx. Now I'm lazy, so I'm going to grab a calculator because I don't want to do that by hand. And when I do that, I get 1.124. So that's my length. Keep this in mind. Just saying. Alright. How do we find the length of the curve from 2 to 4? Well, I said keep that in mind, so let's go back to that. So we had square root dx squared plus dy squared. I would like a dt here, so let's go ahead and put a dt here. The reason we want a t there is because we want this to be an integral defined in terms of t stuff. So similar to before, that's dx squared plus dy squared over dt squared. And then dx dt squared plus dy dt squared. Oh, so it's just take the derivative of x stuff, square it, take the derivative of y stuff, square it, and integrate. Theoretically, we have an a and a b here, and blah, blah, blah. So let's play. So x is that. So dx dt is 2, dy dt is 2t. So we got to integrate from 2 to 4. The square root of 2 squared, which is 4, plus 2t squared, which is 4t squared, dx. Again, I'm going to go ahead and type that into a magical Desmos machine, and it's going to get me an answer. Square root of 4 plus 4t squared. I used x's. Shh, don't tell anyone. And I got... Ooh, my parentheses are wrong there. I'm sorry. Because I already squared the 2. And I got 12.671. Now, I'm just curious. We knew for x stuff that it was y equals x minus 1 squared over 4. And t equals 2 means that x equals 5, and t equals 4 means that x equals 9. So could I have integrated from 5 to 9, square root 1 plus y prime is 2x minus 1 over 4. So x minus 1 over 2 squared. Will I get the same answer? I'm sure hoping so. So let's see. If I go 5 to 9, and then 1, x minus 1 over 2 squared. Yes, I get the 12.671 I got before. The benefit of doing it with the parametric, however, of course, is that we don't have to solve for and write this in terms of y and x. Just makes life a little bit easier. So to recap, we just figured out arc length. That dy dt over dx dt, that's totally how you find the slopes in parametric for first derivative. There is a funky second derivative. Feel free to take a look at your book. Basically, it has to do with chain rule type stuff going on there. So take a look, see what you think.